Hello everyone, we are from West Coast Institute of Science and Engineering College. We done a project called Household Power Consumption Analysis using machine learning presented by SHANMUKH, Heaven, DURGA, PRASAD, SWETHA and MADHURI. Coming to the project, in this project we use some languages like HTML, CSS and Python. Python is a very simple language and easy to understand. In this we use some frameworks called Seaborn, Matplotlib and Flax framework. Coming to the introduction, machine learning is used to analyze social household power consumption. So energy is used growing fast due to technology, population, and economic expansion. Buildings use over 30% of global energy, adding to carbon emissions. Although some smart grids helps monitor energy, forecasting remains difficult because of factors like weather and inconsistent data. Machine learning improves energy forecast by finding patterns in how power is used. Tools like XGBoost and random forest can predict electricity needs more accurately for both short and long periods. Coming to the existing system, regression and time series forecast fail to capture complex energy usages performance accurately. Standard meters collect raw data but do not provide predictive insights. Models like decision trees, SVM, and ANN use historical data to enhance predictions but struggle with adapting to dynamic household behavior. Technique like XGBoost improves accuracy, optimize feature selection, and enable real-time energy monitoring. Coming to the proposed system, a supervised machine learning model is trained to historical data to generate continuous values, predicting power consumption. The model uses background information to estimate the probability of new power consumption values. Supervised regression are trained on all features from training set and evaluated on the test set over time using sklearn, that is sklearn. The applications we are using in smart grid optimization helps in efficient energy distribution and load balancing. Industrial energy management predicts power consumption to optimize manufacturing process. Home energy monitoring assists households in reducing electricity bills through predictive insights. We use the system analysis like software and hardware requirements. Software requirements, Jupyter Notebook, Anaconda Navigator, and OpenCV. And coming to hardware requirements, operating system, Windows, processor, Intel 5, RAM 8 GB, and hard disk 512 GB. We use a project lifecycle called planning, analysis, design, implementation, testing, and maintenance. Coming to the system architecture, first we have to collect the raw data and we do the processing, data processing, and do the missing and find the missing values and do the data translation, time series, train and test the data, modeling training, hyperparameter tuning, model evaluation, and finally output prediction. Coming to the process, firstly we have to open the our folder. So this is the folder we have and go to the music and this you have the project details. These are the templates I have. So firstly we have to open the notebook. For this we use these templates. We have start process HTML, index HTML page, and about and power consumption. Coming to the code, we use Python code and main PNB, and we have the CSV file also. First, we have to open the Jupyter notebook. On this, we have to select the INB file. And look at the project details. We have opened to IPYNB file. First, we have to deploy this code. So go to the kernel and restart kernel and all cells and restart. So the code will execute it. So we have in this we use pandas and imputing data and header files and matplotlib and all regression, random forest and SPM and data boost. These and import pickles. These libraries are using. So after running this code, we open the Anaconda prompt. In this, we have to enter the path for the templates, copy this path and paste it here and enter here and say Python and use the tab to select the power.py and enter it. After enter this, we have the HTTP link. Copy this one for only one time and paste it here. And we have the interface for the power consumption estimation using machine learning. So in this code, we observed the data classification models like yearly wise power consumption and monthly wise power consumption and the box plotic representation and all the things. Coming to the page, we have a start process. We have to click the start process. On this, we have about and power consumption. Going to the about, we have the introduction. Power consumption estimation uses advanced algorithms, including machine learning and AI, to predict energy usage based on the historical and real-time data. This helps optimization energy consumption and reduce cost. And how it works and used in applications like smart homes, industries, commercial buildings, and energy management system to improve efficiency. For advantages, reduces energy waste, power electricity bills, enhance sustainability, help prevent power shortages. And have to click to return home and we have back to the return home. Here we have the power consumption message. Click that and give the values like uh, coming to the global reactive power. So global reactive power means measure the power that oscillates between source and the load but does not contribute to useful work. Higher values indicate inefficient energy usage like inductive loads like motors, refrigeration and etc. And coming to the voltage, measures the electrical power potential differences applied to the household. Standard household voltage is usually 20 to 220 volts to 240 in many countries. And coming to the global intensity, represent the total current in amperes. Higher values indicate more appliances or higher power consumption devices in use. Submetering, energy consumed by specific appliances in the kitchen like dishwashers, microwaves, ovens. Coming to submetering to energy consumed by laundry related appliances like washing machines, dryers, and water heaters. Come to submetering 3, energy consumed by climate related devices like air conditioners, refrigerator, and heating system. So we have to we use these values to use to estimate the power consumption and analysis how value we have to give. So coming to the values, we give some global reactive and power consumption values to give and we have to predict the output. So for this global reactive, I give 0.2 and for the voltage, I give 235 and for this global intensity, I give 5.0 and for submetering 1, give 1.2, submetering 2, give 0.8, submetering 0.5 and detect consumption. So this is our estimated power consumption value 1.18. So coming to the conclusion, using XGBoost machine learning helps predict household power consumption accurately, offering insights for energy optimization. Key factors like water heater and air conditioner usage affect the power usage. So the approach promises better monitoring and personalized energy advice to improve predictions. Additional variables like holidays may need to be considered. Thank you.